Welcome to HVS Technologies. Here we are demonstrating an interleaved Buck-Cascaded buck boost inverter for PV grid connection applications. So here the main project consists of solar panel and through charge circuit we are going to charge the battery. We are using a lithium ion battery for giving the high efficiency, and through this cascaded circuit of Buck-Cascaded buck boost circuits, through this one we are going to give the input to the inverter, and from the inverter we are going to drive the motor, and from this motor driving we are going to measure the motor RPM, and this was given to the MATLAB through this USB to converter, and as well as we are going to measuring the battery voltage and solar panel voltage and speed of the motor will be displayed on this LCD. And this all controlling section was done by the PIC 16F877A 40 pin controller. So from here A0 and A1 pin we are going to measuring the voltage, and from this C port and E port we are going to give the pulses to this inverter as well as Buck-Cascade circuits, and you can see the RPM on the MATLAB screen. So how to interface a USB TTL to the microcontroller, to the laptop, we did a video, you can check from there, and run the code by entering the COM number. So let us explain the circuit operation. So according to the circuits, we are going to give the solar panel grid connected to this circuits. So in this one, two sections are connected, that is called as cascading of a buck boost converter. So whenever the voltage is above the 14.5 volts, then my microcontroller will do the buck operation on the circuits, as well as whenever the voltage decreases below 10 volts, so it will do the boost operation from the circuit only. So based on the buck boost conversion of circuits, we did the generate the voltage and given to the HB circuits, that is the inverting, and from there we are going to generate the AC voltage and given to the load. So in this circuit one, these inductors and capacitors are charging, discharging whenever the buck boost operation is giving signals giving from the PIC microcontroller one. So here we have provide the alternate charging circuits, that is transformer also you can provide, you can charge the battery. So this is a solar connection, and just unplug this transformer and plug the solar panel, and then switch on this one, the indication of indicating the battery charging level. And this is the whole circuit consists of this Buck-Cascaded buck boost converter. We have the two switches, one switch to on and off this main motherboard, and another switch to on and off this motor. Okay, so let us see the demonstration. Switch on that, the motor will be rotates, and the motor RPM will be plotting on the MATLAB screen. Okay, you can see the motor RPM range. So coming to this motherboard, we have the reset button and a 10 kilo ohm for the reset switch, pull up purpose, and the capacitor of 1000 microfarad and 7805 to give the 5 volts to this microcontroller, and is a power lead indication, and there is a processing indication. When its blinking rate is there, then you can observe that the processing going on. And these two are the resistors of 8.2K and 3.3K of two potential divider, means we are getting the 12 volts from this one and 12 volts from the solar panel in order to make convenient voltage to the PIC microcontroller. So we are going to make it 1:3 ratio. Then we will measure the voltage and display it on the LCD. We are using a 16:2 LCD, and the motor ratings are 230 volts, 50 watts of power, and inverter also 12 volts DC input and 230 volts 50 watts of power output. And this Buck-Cascaded buck boost converter of operating voltage of 10 to 14.5. So whenever the 14.5 above, it will do the buck operation, and 10 below it will do the boost operation. And we are using a lithium ion battery, so that is of 12 volt 3 amps. So totally 36 watts of power generating from this battery. So the battery charging should be done at least of 8 hours. So whether if you used or not, then you should keep this battery for 8 hours, that will get fully charged. Thank you for watching demo.